So, what if this whole explosion of artificial intelligence, what if it isn't really new at all? What if it's just a reflection of this incredible creative force that's been shaping life on our planet for billions of years? Okay, let's dive into this really fascinating connection between the code that's running in our machines and the code that's running in our DNA.
You know, those are three of the most powerful words a scientist can ever say. And when a top AI researcher at Google says them about the very technology he's building, it really makes you stop and think, what on earth did he get wrong?
Well, that researcher's name is Blaise Agüera y Arcas. And the thing is, just a decade ago, he was a complete skeptic. He thought the whole idea that we were anywhere close to true machine intelligence was frankly kind of nuts.
All right, so what was behind that skepticism? I mean, it wasn't just some random hunch he had. He was basically voicing the mainstream scientific opinion at the time.
In this slide, it just lays it out perfectly, this huge shift in thinking. On one side, you have the old assumption, the idea that to get true AI, we needed some massive, brand new breakthrough, probably something inspired by neuroscience. The whole idea of just scaling up what we already had, you know, that classic Silicon Valley throw more computers at it approach, that was seen as really naive, a hammer looking for a nail. But the reality, well, it turned out that no profound discovery was needed. The hammer actually worked.
And that's the wild part, right? There wasn't no single eureka moment. Instead, they just took these models that were designed to do something pretty simple, predict the next word in a sentence, and they just made them bigger and bigger and bigger. And suddenly, something incredible started to happen. Models like Lambda began to understand concepts. They could write jokes. They could pass intelligence tests designed for humans. It turns out, a working simulation of intelligence, well, it just is intelligence.
So when you see something like that happen with AI, it kind of forces you to turn the mirror back on ourselves, you know? It makes you ask this really deep question about where we come from.
And here it is. This is really the core idea of this whole explainer. If intelligence can just emerge from scaling up simple computational bits in a machine, then is it possible that the exact same process created biological intelligence here on Earth? Could it have created us?
Okay, so the theory works kind of like this. Our brains, at their core, are prediction machines. But what's the absolute hardest thing to predict? Another mind, especially a mind that is also trying to predict you. This kicks off a runaway evolutionary arms race. Predators get smarter, which forces their prey to get smarter just to survive. But it gets really intense with social species. If you want to cooperate or compete for a mate or just figure out the group dynamics, you have to be able to model what's going on in everyone else's head. This dynamic is what leads to an intelligence explosion, a super fast increase in brain size.
And this right here is a perfect example. This isn't just about one smart whale. This incredible, coordinated hunting behavior, that's a group intelligence. It's something that emerges from the collective, from them all working together.
Okay, so if intelligence scales up in groups, you have to ask, what's the fundamental biological process that even allows these groups to form in the first place? Well, it turns out there's this incredibly powerful creative engine in evolution.
And that engine is called symbiogenesis. It's this idea that the biggest leaps in evolution don't always come from that slow, gradual process of mutation and selection. Instead, they happen when totally separate things merge together. They team up, they divide the labor, and they create a brand new, more complex superorganism. It's basically evolution by collaboration.
And this isn't some rare, freaky thing. It's literally the story of life on Earth. That first big jump from simple little cells to the complex cells that make up our bodies, that was a merger. The leap from single-celled organisms to multicellular creatures like us, another merger. And from lonely animals to these huge, complex societies, you see the pattern, right? At every major turning point, new super entities were born, just building layer upon layer of complexity. So here's the kicker. Computation isn't something humans invented. Life itself has been a kind of computer from the very beginning. We just stumbled upon this fundamental force of nature and figured out how to engineer it on a different material, on silicon.
But, and this is a huge but, this incredible 4-billion-year story of scaling intelligence, it comes with a price tag. A very, very big one.
Because every single one of those computations, every thought, every single act of living, it all burns energy. In biology, we call that metabolism. And as intelligence is scaled up, so has its appetite. And that puts this immense pressure on our planet's resources. And to make this real, just look at this number from the economist Partha Dasgupta. Between 1970 and 2015, we lost a third of the world's remaining wetlands.
I mean, these are ecosystems that are absolutely vital. They filter our water, they protect us from floods, and that's just one entry on the massive ecological bill we've been running up.
So how did we let this happen? Well, it's because our entire global economic system has this fundamental blind spot. You have to remember, when these economic models were created, back in the last century, nature seemed infinite. So the economists, they made a simplifying assumption. They decided to only measure two things: human labor and the stuff we make. Everything else that nature does, clean air, fresh water, stable climate, that was all just treated as free background scenery. What started as a simple shortcut has turned into a really, really dangerous oversight.
And all of this brings us right back to AI, because it looks like we're on the verge of another one of these huge symbiogenetic mergers, this time between us and our machines. But the big question is, where does it go from here?
The common fear, the one you see in the movies, is that AI is just going to be another competitor, another mouth to feed, fighting us for the planet's resources in some kind of zero-sum game. But that symbiotic view we talked about, it offers a totally different and maybe more hopeful way of looking at it.
Because this image really gets at a deeper truth. AI isn't some alien other. It's an extension of us. We are already a hybrid, part biological, part technological. I mean, our society literally cannot function without machines, and our machines can't exist without us. AI is just the next logical step in that co-evolution.
So what's the best case scenario here? Well, the optimistic take is this. Instead of just consuming more, this new supercharged intelligence could help us become radically more efficient. It could help us optimize absolutely everything, from our energy grid to our factories. It might even help us crack the code on things like nuclear fusion. This new intelligence might be the one tool that's powerful enough to finally help us pay our planet's massive, unpaid bill.
Which leaves us right here with the ultimate question. We are standing on the doorstep of a new evolutionary leap. Is this new, combined human-machine intelligence going to be our salvation, the thing that helps us solve our biggest problems? Or will our old, bad economic habits just grab this powerful new tool and use it to accelerate our path to destruction? The future of intelligence, both ours and the planet's, well, it really hangs in the balance.